In this section we will see what is happening, the demand for data analytics, and we will look at the different elements of data analytics. This picture shows Google trends. This was up to 2017. See, for example, the blue represents the data scientist, this orange represents the statistician, operation researchers. You see the trend is it is increasing. That means people are searching in the Google search engine the word data scientist more number of times. See the search count is it is increasing. That means there is a demand for that particular say job. You see, if you look at this is the newspaper clipping from Times of India. There are so many news are coming about data scientist and the future requirement of data scientists. You see the data scientists earning more than CAs and engineers. You can look at this link for further. And you see the demand for data analytics. This is also newspaper clipping, with companies across industries striving to bring their search and analysis department up to speed. Demand for qualified data scientists is rising. So there is an emerging field. So many companies is looking for the qualified data scientist. So if you take this course, at the end of the course that you may be qualified for getting into these companies. Many times you see what is data analytics, statistics, data mining, optimizations. These are students having different understanding on that. So when we say data analytics, there are different elements. One is statistics, next one is the business intelligence information systems, then modeling and optimizations, then simulation and risk. We can say if you are able to do what if analysis, that is nothing but sensitivity analysis, visualization, data mining. These are the components of data analytics and how these different domains are interrelated. Next we will see what kind of skill set is required to become a data analyst. Then we will see the small difference between data analyst and data scientist. See, to become a data analyst is the basic fundamental knowledge is you need to have knowledge of mathematics. Next you need to have the knowledge of technology. It is nothing but hacking skill. Hacking skill in the sense if the data is given, hacking is done in the looked at the positive way, how to use the data to get more informations. The next skill is business and strategy acumen. You should have the knowledge of the domain, knowledge of the business, and you need to have the strategy acumen. So these three skills are required for a good data scientist. It is very difficult to have one person will have all these three skills. That is why availability of good data analytics is becoming very difficult, because somebody may be very good at mathematics, but they may not have very good knowledge in business. Some people may have very good at technology, they may not, technology in the sense information technology, they may not have good knowledge on the business knowledge or and so on. So we need to have the combination of all these three skills, otherwise the group of people, some people from mathematics department, mathematics area, some people from computer science, some people from the domain knowledge, they have to work together to form a good data scientist team. So these forms data science. Now what is the difference between data analyst and data scientist, and the difference is what kind of role they are doing. For example, the role of a data analyst is, see, in a business context, he may have the knowledge of business domain. For example, if he is good at doing analytics in the area of marketing, he can be called as a marketing analyst. If the person is from finance area, he can be called it as a finance analyst. So he is the analyst, data analyst. But the role of data scientist is little bigger, because the data scientist need to have the knowledge of advanced algorithms and machine learning and able to come out with a data product, which I told you in the previously. So the data scientist can come out with a data product. Okay. In this course we are going to use Python. In this, in the next lecture, I will tell you the basic introduction about the Python. Here we will see why we are going to use the Python, because Python is very simple and easy to learn. Most importantly, it is a freeware and open source. It uses interpreted. It is not the compiler. Suppose what you mean by compiler and interpreter is, you need a compiler to solve the whole program, but interpreter need not be in that way. It can solve, even you can interpret one sentence also, one line in the programming line also. It is dynamically typed. Dynamically typed in the sense, in some other programs every time you have to declare the variable, what is the nature of the variable, whether it is integer, whether it is a float, but here you need not do. It is dynamically, it takes the value. It is extensible. Extendable sense, if you make a code in some other language, that can be extended with the help of Python, and can be embedded. Embedded in the sense, you have made some program in Python, it can be embedded with some other platforms, and it has extensive library. The usability of Python is, it is a desktop and web applications. It can be used for data applications, it can be used for networking applications. Most importantly, it can be used for data analyst, data science, can be used for machine learning. It can be used for IoT, Internet of Things, and artificial intelligence applications, and can be used for games. The another reason for choosing Python is, most of the companies, they use Python as a language in their company, like for example Google, Facebook, NASA, Yahoo, and so eBay, they use Python as a programming language. In this Python also we are going to use a Jupyter notebook. In the next class I will explain you, because it is the client server application, is edit code on web browser, easy in documentation, easy in demonstration, and user friendly interface. This was the last session of this lecture. We will explain 4 different level of the data. One is the type of variables, level of data of measurement, compare 4 different level of data, we will say nominal, ordinal, interval, and ratio. Will we see that what is the usage of knowing this different level of data. The one way for classifying the data is the categorical data, one is the numerical data. In categorical data, you see marital status, political party, eye color, these are categorical data. Numerical data, it can be discrete or continuous. Discrete data may be a number of children, defects per hour, so it is the discrete data. In the continuous data, maybe weight, voltage, these are the example of continuous data. So what is the difference between discrete and continuous is, you say a number of children, you may say 2 children or 3 children, 2.5 children is not possible. But in continuous, if you look at between 0 and 1, the numbers are continuous, there is infinite number of values are there between 0 and 1. So it is a continuous variable. Next we will see the different level of data measurement. Previously we have seen the classification of data, we classified as the categorical data, numerical data. There is another way of classification is classifying into nominal data, ordinal data, interval data, ratio data. We will look at what is nominal data. Nominal scale classifies data into distinct categories in which no ranking is implied. The example of nominal data is gender, marital status. For example, gender, suppose you are conducting a questionnaire, suppose you have captured the gender male 0, female 1, this 0, 1 represents just the gender. You cannot do any arithmetic operations with the help of the 0 and 1. For example, you cannot find out the average. Software will give you some number, but there is no meaning for that. Similarly, marital status, whether it is married, unmarried, this is the example of nominal data. The next level of data is the ordinal scale. It classifies data into distinct categories in which the ranking is implied. Here the numbers are the ranked. For example, you may ask the customer to give you a ranking about their level of satisfaction, for example satisfied, neutral, unsatisfied. The faculty ranking, for example professor, associate professor, assistant professor, you see that there are rank is followed. For example 1 is professor, 2 associate professor, 3 assistant professor. Student grades A, B, C, D, F, these are ranking because the numbers 1, 2, 3 represent the rank. The next level of data is interval scale. The interval scale is an ordered scale in which the difference between measurement is a meaningful quantity, but the measurement do not have true 0 point. The example of interval scale is, for example, year. Say now say this year is 2019, you can add and subtract something. You can add another 5 years 2024, or you can subtract another 9 years 2010, but you cannot multiply. If you multiply that number, for example 2019 and 2020, you will end up with a big number. There is no meaning for that, because there is no meaning for 0. The another example of interval scale is your Fahrenheit temperature. For example, in the Fahrenheit scale, the 0 represents freezing point, but it is not the absence of the heat, but absence of the temperature. But at the same time, in the Kelvin, for example minus 273, it is absence of heat. So, Kelvin will be the some other scale that you will see the next one. The ratio scale is the ordered scale in which the difference between the measurement is a meaningful quantity and the measurement have the true 0 point. Weight, age, salary, and the Kelvin temperature comes under ratio scale, because 0 Kelvin, that means the absence of the heat. So, in the ratio scale you can do all kind of arithmetic operation. For example, the nominal you cannot do any arithmetic operation, in ordinal you cannot do any arithmetic operation. In the interval you can add and subtract, but you cannot multiply. But in the ratio data you can do all kind of arithmetic operation. You can add, you can subtract, you can multiply, you can divide. You see the usage potential various level of data. For example, the usage potential of nominal data is not that much. The next one is ordinal, next one is interval, next one ratio. So, the ratio data is having the highest usage potential. The nominal data is having the least usage potential. This is more important. Why we have to know the different types of data? Because these types of data is helping to choose the right analytical tools for doing analysis. For example, if the data is the nominal data, you can do only non-parametric test. For example, the data is ordinal, here also you can do only non-parametric test. But if the data is interval, you can do parametric test. You see that interval you can do all of the above plus addition and subtraction. In the ratio you can do all of the above plus multiplication and division, and statistical methods you can go for parametric methods. So, the purpose of classifying the data into nominal, ordinal, interval, ratio is to choose the right analytical tools, whether it is a parametric or non-parametric. The other reason is sometime if we want to do a non-parametric analysis, that is used only for nominal data. Sometime the students the data may be nominal, but they may go for a parametric test. That should not be done. That is the purpose of knowing what kind of what is the nature of this data.